The final topic we have to do in further maths is moments, something you might have seen in science. So this is the final topic and it is a short one. And after this we can go on to revision, and this should only take us really 2 classes. So here's a few notes just taken from the textbook. The moment of a force measures the turning effect of the force. A moment is a force multiplied by a perpendicular distance. So when a system is in equilibrium, the sum of all the clockwise moments about any point is equal to the sum of all anti-clockwise moments about a point. Now we in these first few questions have to find 2 unknown forces, and what we need to do is we take the moments about the point where one of these forces acts, and then we have to equate vertical forces. So it's best demonstrated with an example, and here is an example. AB is a uniform rod of length 8 meters and mass 4.8 kilograms. It rests on 2 supports, one at C where AC is 1.6 and the other at D where DB is 2 meters. Find the reactions at C and D. So what we are actually asked to find is the value of these reactions that act upwards at C and D, and we'll call them R and S. We normally call a normal reaction R in previous exercises. So we have to find these 2 reactions. Now let's read through the question just with a little more detail. AB is a uniform rod. So the reason why it says uniform is so that you can put an arrow exactly in the middle. The weight of the rod acts through the center, and the weight in this case is 4.8 times 10. The weight is 48 newtons. So because it's uniform, these are all going to be uniform, you can put an arrow coming down halfway along the length 8 meters. The next thing you have to do is you have to put in your 2 supports, and you have to be able to figure out what these values here are. So the whole length of the rod is 8 meters, and the information in the text in the question helps us to figure out what each of these individual lengths are. And you need those individual lengths to do your calculations. So let's read through the questions and see how we get these. So it tells us that there is a support at C where AC is 1.6. So you do a support here, something holding up the rod, and call it C, and it tells us that the distance AC is 1.6. So that's how you have 1.6 there. And you know then that this is 2.4 because this is half of the rod, and half of the rod is 4 meters. So that's just whatever's left to bring up to 4 meters. For the support D, so you'll draw a little support here, and it says that DB is 2 meters, so that's where we get this 2 meters from. And once again, subtracting from 4 meters because that's half length of the rod, that's how we get this. So you need to get all these distances, all these lengths in by reading through the question and making sure your supports are in the right place. So you will have to draw a diagram each time for all of these questions, and then you'll get on to finding or using a method to find the value of R and S. So the first thing you're going to do is you want to pick a point, either this point here where R acts, or this point here where S acts. So what I've decided to do is I'm going to stick with the first one. I'm going to take moments about this point C. That's what I've written here. I'm going to take moments about C. And look at all the forces that are acting around C. So I want to show to you that this force I should say 48, I've wrote something out. This force of 48 newtons acts at a distance of 2.4 meters from C. So look at the yellow lines here. So 48 newtons acts at a distance of 2.4 meters from C. And look at the direction. Think about 48 newtons and whether it is acting in a clockwise manner or an anti-clockwise manner around C. This 48 newtons is acting in a clockwise manner. Now in a different colour pen I'm going to look at the other force that's acting on the rod around point C, this force S is acting on the rod around point C at a distance of 4.4 meters. And that force is acting in an anti-clockwise manner. So we have two forces acting around point C. One of them is acting, the yellow one is acting in a clockwise manner, and the purple one is acting in an anti-clockwise manner. Now remember that a moment is equal to a force times the perpendicular distance. So we have two moments here, a yellow moment and a purple moment. So our yellow moment here is our clockwise moment. The force multiplied by the distance to point C, that is our clockwise moment. And the purple one, the force S, the unknown force, multiplied by our perpendicular distance to point C, that is our anti-clockwise moment. So we have to equate the clockwise moment with the anti-clockwise moment about C. So it's just a matter of multiplying things out and rearranging. So 48 times 2.4 is 115.2, and then divide that by 4.4, you get your value of S. S is 26.2 newtons. So that's the first part you have to do for all of these questions. You equate the clockwise moments with the anti-clockwise moments. And then the second part, which is here, you equate the upward forces with the downward forces. So the downward force is acting on this rod. The downward force is the weight. So the weight is 48 newtons. Now I just see I have to change that to 48. So what I have here is I have R plus S. These are the two normal forces, normal reactions acting upwards. And this is the weight acting downwards. So R plus S, they have to equal 48. But now that you know what S is, you've worked it out, you can figure out what R is. So there's R and there's S. That's the question answer. So I'll do question 1 of the exercise. AB is a uniform rod of length 12 meters and mass 8 kilograms. It rests on two supports, one at A and the other at C, where CB is 2 meters. Find the reactions at A and C. So I'm going to get a horizontal line, and I'm going to call it AB. At one end we have A, at the other end we have B. It is 12 meters long and it has a mass of 8 kilograms. So halfway along it, I have 80 newtons acting downwards, because 8 times 10. 10 is the acceleration due to gravity. It rests on two supports, so we have to decide where these two supports are going to go. And one at A, well, that's easy enough. Do a wee triangle here. And one at C. Now where's C going to go? It says CB is 2 meters. So from C to B is 2 meters. So first thing I'm going to do actually is just tell myself that that is 6 meters. And so is the other half, which means that if I have C here, this is going to be 2 meters. And we have a remaining 4 meters here. So I know that's 6 because it's half of 12. I know that's 2 because CB is 2 meters. And I know that's 4 because 4 and 2 is 6. So the question asks us to find the reactions at A and C. So find this R value, find this S value, the reactional forces against the supports. So what we're going to do is we're going to pick either A or C. Pick A or C, and then look at the moments around A or the moments around C and equate those. So I have something already drawn here. What I've decided to do is I've decided to take the moments around C this time. So I'm focusing on these two forces and the distance from C. So I'm going to look at the clockwise forces first. So the clockwise forces acting around C, that's going to be our R. And R is how far from C? R is 10 meters from C, which is why I have done R multiplied by 10. Now I want to look at the anti-clockwise moments. The force acting in the opposite direction. This 80 newtons acts in the opposite direction, and it is at a distance of 4 meters from C. So when you take the force and multiply it by the perpendicular distance, you get the moment, and you equate the clockwise moments with the anti-clockwise moments. So 10R is equal to 320, because this is 80 times 4, and this is 10 times R. So you get your value of R. The second part, to find S, what you'll do is you'll equate upwards forces with downwards forces. So our two upwards forces are R and S. R and S. And our downward force is the weight, 80. Now you've got the value of R, so just subtract it from 80 and you get your value of S. We'll do one more. So instead of taking time to read through it, this is just the diagram that I've done, and I'm going to just jump into how I have equated it. So I have taken moments about, in this case, moments about C. So I'm focusing on these two forces and the distances from C. So the clockwise force is our 50 newtons, and it is at a length of 3 meters. So that's 50 times 3. Our anti-clockwise force is our S value, and it is at a distance of 5.5. So 50 times 3 gives us 150, and then we have to divide that by 5.5 to get the value of S. So S is 27.3. Upwards forces, the upwards forces are R and S. So R plus S has to be equal to 50. So then subtract your value of S from 50 and you get 22.7. These are all newtons. Moving on to how you would start exercise 22b. Instead of having supports, exercise 22b has a rod hanging using 2 strings. So a uniform rod AB of length 16 meters and mass 5 kilograms is held horizontally in equilibrium by 2 strings, one at A and the other at C, where AC is 14 meters. Find the tensions in the 2 strings now. So as before, you just draw a horizontal line AB, and because it is 16 meters and it's uniform and it has a mass of 5 kilograms, we have 50 newtons acting downwards, exactly halfway along, and halfway along is 8 meters. So that's how I get that distance. It says that it is held horizontally in equilibrium by 2 strings, one at A. So we have a string here at A, and we also have another string at C, so I should have a C in here. That says AC is 14 meters. So that's where I get this 6 from, because A to C has to be 14 meters. So the only real difference here is that we're being asked to find tension instead of a normal reaction. So just take moments about either A or C. And what I've decided to do is take moments about A. So if I'm taking moments about A, well then the 2 forces that I'm concerned about are this 50 newtons and this tension. So I've labelled our tensions T1 and T2. So the clockwise moments is this 50 newtons and it acts 8 meters from A. So that's why I have 50 times 8. The anti-clockwise moments is this other tension and it acts 14 meters from A. So that's why I have 14 multiplied by the second tension, T2. So rearranging, you can find the value of the second tension. And as before, the upwards forces and the downward forces should equal. So T1 plus T2 should equal to 50 newtons. Because we know this value of T2, subtract it from 50, and we get our value of T1. And that's the only difference from the previous exercise, just that we're dealing with tensions. You still pick a moment about either A or C, and then you'll equate your vertical forces. So have a go at the first two exercises of the Moments chapter and see how you get on.